All right. So you guys have, how's chapter 1 homework going? There's a lot of it? Get used to that. That was my favorite comment I got on my little evals was,
He's alright, he's okay. Damn, what's up with the homework?
but homework's the way we learn, how we get practice. If you get behind, just remember, come see me. I can cut it down, get you caught up. Just not going to do that the whole semester for you, so be careful. Any questions? Maybe I can make an announcement that might engender some questions. Our first quiz will be this Wednesday. Chapter 1. Alright, so any questions on chapter 1 homework? Yeah.
On section 1.2, number 16.
Oh, and real quick, before I forget, did everybody get if you checked your email this morning, did you get my little reminder about the survey? Okay. So check and make sure you're getting emails from me. If you didn't get that email, double check your email address in WebAdvisor, because I will be emailing out, not all the time, but sometimes I'll email out some important stuff.
Why were you awake at 6:30 in the morning?
Because I have to drive my girlfriend out to her school, and she's got to be there by 7.
Oh my God.
Yeah. That's that, yeah. Any other questions from our, it was number 16. Oh yeah, the Federal Trade Commission obtained the measured amounts of nicotine shown in the table there. So the Federal Trade Commission, do you think that this data would be unbiased, or do you think it would be biased somehow? What would you hope you could say? So it's on page 10, number 16, and that's the one, right? The Federal Trade Commission?
Yeah.
Okay. You would hope you could say it's unbiased, right? Because if it were biased, that would mean they're trying to sway people one way or the other, and they're supposed to be, the Federal Trade Commission, they're supposed to be completely just, here's the facts. They're not supposed to try to make decisions for you, right? Or sway you to a certain decision. So I can understand there's a growing, there's always been distrust in the government forever. But they seem to be trying to tell us we should be able to trust them. Right? Yes, sir.
Number 24 on
Is
the
that cool?
same.
But if you want to say biased and you want to explain yourself, that's great. It's really just making sure you understand what the hell unbiased and biased means. Yeah.
Number 24 on the same section 1.2.
Oh, anybody ever done biology? They ever heard of Mendel? Yeah. He had to do his little charts and the green peas and the yellow peas and whatever. One of his experiments with peas yielded 580 offspring with 152 of these peas. 26% had yellow pods. So 26% yellow. He predicted, oh, where'd it go? There it is. His theory said that it should have been 25. Now, can you imagine somebody up there saying, but look at his theory said 25%. He found 26. He's crazy. I mean, that's really what this is asking. Would you be able to make that claim that, well, he's just full of bullshit. Look at him. He said there'd be 25 and we saw 26. So, would that make sense for somebody to say that, or is that close enough? And we're going to rigidly just define close enough.
That's what I was wondering.
The interesting, yeah, they're going to make it right now. They've got to make it pretty obvious. Now, here's the gray area. If he says 25%, but he gets 26%, that seems okay. What about 27? Still okay. What about if he sees 31%? Is that still okay? See, and we all have a different place that we'd start to go, no, that's not good enough, dude. You with me? Yeah. Right? So like if you go to a fair, and I think I've already shown this example once, but they say I can guess your weight. I can guess your weight with it to within 80 pounds. You're like, well, screw what? So it's that acceptable, if you do it within 5, that's cool, that's pretty good, you're pretty good. So he got within 1% of what actually was seen from a sample. A decent sized sample, but it's still just a sample, so that's pretty damn good. Theoretical, what you saw, holy crap dude, you're good, right? Later we're going to define how far away from theory would a sample have to be to say the theory looks to be wrong. In fact, that's a huge piece of statistics. We think it's this, let's go take a sample and test that. Well, you got to know how far away is bad. You with me? And again, real life comes in and says there's not going to be a hard line definition. It's going to depend on the situation. How far is bad? How far seems to say, no, you're wrong, it's somewhere else. Okay, so a lot of you guys are out there like, what the hell was the answer to that question then? Is that good enough? Yes. Yes, sir.
Can we say there's some statistical significance in the discrepancy, or?
The discrepancy, I'm glad you said that. This discrepancy is not statistically significant. If it was, then you'd say, well, then there's a difference between your theory and what we've seen. There is a difference. There's a 1% difference. Is it statistically significant? No, we're saying that's close enough, right? Now, if he saw 40% in a sample, is that statistically significant? Hell yeah. With me? Yes, sir.
So can you characterize like his accuracy as being statistically significant? Or is that not?
You gotta be careful. We refer to, there's a few things we can refer to as statistically significant. And most of the time we refer to what we see versus what we predict. Or is it more likely to show something is wrong? Or is it more likely that he just happened to pick a sample where it went one way or the other? You with me? So if I said the average age of gross fund students is 28, and I took a sample of 1,000 gross fund students, and the average age was 27 and a half, you're going to go, sounds pretty good, dude. Right? So it wasn't statistically significant. It wasn't far away enough.
So statistically significant means far away enough?
Exactly. That's what it means for the most part. Yes, that's what it's used most for. Here, I wouldn't say this is statistically significant. It doesn't mean that he was bad. It just means that the difference isn't statistically significant. It actually means that his theory looks to be good. Yeah.
The example they were given in the book about statistical significance was the Atkins diet, and how over a year the people lost on average 2 pounds, and how that amount was statistically significant but not practically significant.
Exactly. That's the difference between statistically significant and practical. So if so in that case with the Atkins diet, 2 pounds was enough to say that even though it was just a sample, it probably is true for the whole population that there would be some weight loss on average, right? If I would have gotten like a loss of ½ a pound from a sample I took, well, maybe the whole population would actually lose on average nothing. It's close enough to 0. But maybe 2 pounds was statistically significantly different enough from 0 to say, yes, there is a weight loss. But would you want to subject yourself to this possibly heart attack inducing diet? I don't know if anybody follows Atkins, but where you eat as much bacon as you want to in the morning, for example, wrapped around filet mignon. Oh, you don't want to do that. You do lose weight, but is it worth it? Is it practically significant? No. My good example would be if it turns out if you slept 20 hours a day, you could live a month longer. And it's statistically significant. A month is actually, the sample they took is so huge that it actually couldn't possibly be 0 months. It has to be some, or an average of 1 month saved on your life. Would you do that? Some of you might already, and I'm jealous. You're like, I'm awake now for this class, man. So you're gonna live a month longer than I am. Yay. But you guys kind of with me? Is it practically significant? Hell no, I'm not gonna be awake just 4 hours a day and then sleep away my whole life just so I can live a month longer. That's a little crazy. You kind of with me? Yes.
So is determining something statistically significant subjective? But because like
yes.
in the case of the Atkins diet, I didn't think that it was significantly, statistically
Now,
significant.
they had to tell us in that one that it was, right? They told us it was.
Yeah.
Because we don't know the math, and they didn't give us the data for us to determine ourselves.
But does the math?
But the interpretation of it is subjective to a degree. I don't know if you guys are semi with me at all, but if you do a study, and anytime you take a sample, if I take a sample of students, I think the average age is 30, and I sample 30 students, and their average age is 20. Am I definitely wrong about that I think it's 30? Am I definitely wrong? No. If I take a sample of 30 students and their average age isn't what I predicted for everybody, it's just a sample. It doesn't tell me I'm definitely wrong. I forget where I'm going with that. Shoot. But we don't know yet what has to go in. We don't even know the formula yet to figure out this number. It's actually a probability. Is it more likely that our sample was just swayed one way or the other? Or is it more likely that the whole population is actually different than what I thought it was? You with me? So if the actual average age of Grossmont is 25, and I think it's 30, and I take a large enough sample, what should that average age for that sample be? If it's a randomly selected sample, the average age for that sample should be close to 25, because it's the real one. And I think it's 30. If I take a good, large enough random sample, its average should be close to 25. There's actually some math we can do to figure out the probability that it could be 30. You with me? Let me do this again. I desperately want you guys to be with me, because this is the whole idea. It's coming down later, but we're doing little parts of it through every chapter. So I think it's 30. The actual is 25. I take a decent sized sample, and I find the average to be close to 25. If I find out the probability that it might still be 30, because it's just a sample, right? It might still be 30, it's just a sample. But if I do the math and figure out the probability that it is 30, given what I've seen is 0.003%, there's a 0.003% chance that, given what I've seen so far, the average age is actually 30. And what's more likely? It's actually less. You with me? That would be statistically significant findings. That there's such a small chance that it is what you think, that it probably isn't what you think, based on what you see. Okay. If you didn't quite get all of what I just said, it's okay. We're building up that way, but I want to give you a little bit of a precursor where we're going. Yeah.
At what point would you, if you guessed that it was 26 and it was actually 25, at what point would you realize that you were wrong?
That's the key question. I really love that question, because it tells me you kind of followed what I was saying, which is always good validation. But statistics is the most truthful math course, because it always says, shit, I don't know. Because we almost never look at the whole population. We have no idea what the real answer is. If we can't look at the whole population, we can only go by what it looks like. So if my original guess is really close to what it is, I might never disprove my original guess, unless I take a crazy huge sample. Because what happens, the larger the sample I take, how do I feel about what I see?
More accurate.
I feel much better, especially if it's randomly selected too. If I just pick all my friends, all my Facebook friends, I got thousands of them, well, it's going to skew your data. You don't know shit. They're probably all close in age to you and all that kind of stuff, so it's not going to work. All right, how are we doing so far? So a lot of what he just said is a little bit ahead of us. You with me? But I have to explain why they're talking about statistical significance and all this stuff right now. They're getting you ready for this. That's actually, everything I just said is going to be chapter 8. So it's a little ways off. Right? Any other specific questions from chapter 1? Yeah.
26.
I guess, is this section 1 too?
Mm-hmm.
Oh yeah, this is a good one. All right. I always get questions on this one. Let me put it up here real quick. How many of us don't have a book yet? Are you willing to say? Okay. Okay, there's. Oh, you are on. Stay on. There it is. Slowly but surely it's coming. There you go. That's pretty good. You guys can see that? Everybody focus. So study compares surgery and splinting for subjects suffering from carpal tunnel syndrome. So you either go in there and do some surgery, which I always vote against because the minute they go in there they can screw other things up, or they just splint it off and let it kind of heal itself. So surgery and splinting. Among 73 patients treated with surgery, there was a 92% success rate. Among 83 patients treated with splints, there was a 72% success rate. Now, two things that always come up. Students tell me something about the sample sizes. What do you think they might mention about the sample sizes?
Not the same. Yeah.
Yeah, they're not small actually, but I understand what you're saying that, but they're actually a decent size. They're
Not
not,
the same.
they could be better. It could always be better if it's bigger. And they're not the same, I get that a lot, but that doesn't matter. Doesn't matter at all. If I'm comparing percentages, as long as they're both a decent size and they're both randomly selected, they don't have to be exactly the same.
Okay.
They only have to be the same if you actually have the same people, like before I died and after I died. If you lose somebody, it's like, where did they go with? They don't have to be the same size. I'm talking about percentages. And hopefully we all understand percentage enough. I always get the interesting thing about, well, there were more people, so there was probably a higher success rate. Well, here it's actually backwards, for one thing, but you guys kind of with me? I don't know why that comes out. Percentages don't care. Calculations using those results show that if there really is no difference in success rates, then there's about 1 chance in 1,000. Wow. So let me translate that. Calculations that we don't know yet, that I was talking about earlier, so they still have to tell us if it's statistically significant or not. There's a 1 chance in 1,000 of getting success rates like this if they really are truly the same for everybody. I mean, the first thing you think when you see a 92% success rate for those guys for surgery and a 72% success rate for splints, what's the first thing your brain says about which one would you choose?
Surgery.
Because your brain says, 20% more likely, dude. What the hell? But it's still only 73 and 83. It's a decent sized sample, but it's still just a sample. So by doing the math, we don't know yet, so they still have to tell me, we find out that there's only a 1 chance in 1,000 that the success rates are actually the same for everybody. So what's more likely then? That they're the same or that they're not the same? Yeah, there's only a 1 chance in 1,000 that they're actually the same, given what we saw. So it's more likely that they are not the same, that they are in the direction that this study shows. Yeah.
Okay, I guess that makes sense too, but I thought it was, if there really is no difference in success rates between surgery and splints, I thought that means that they actually were the same success rate.
That's what I'm saying.
No, like instead of being 72 and 92, they would both be like 80.
Yeah, so remember, the 72 and 92 are from samples.
Yeah.
In reality, it could be 80-80, couldn't it?
Yeah.
I just happened to
But
pick a
that's not what it's
sample
saying.
accidentally that showed this. That's exactly what they're saying. What's the chance that that's true? We don't know. In statistics, we never know. But what's the chance that that's true? 1 in 1,000 chance. So what's more likely? That ain't true. What's more likely? There really is a difference. You with me? So for a lot of these problems is there a difference or isn't there? And then math will show us, it'll tell us the probabilities, and that's why it's subjective. If there was a 1% chance, for somebody that's good enough, and for somebody else that's not good, 5%, 10%, 0.1%, it's a little bit subjective there. Especially depending on how bad is it if I make a mistake. Then I'm a lot more worried about which way I'm going to go. Okay, so does everybody sort of understand what's going on with this problem? There is a difference, we can see it, but they're just samples. Is there a true difference for the whole population? I don't know, but the calculations that we can do later say that there's only a 1 chance in 1,000 that there actually are the same. They must then probably be different. Yes?
Okay, I think I know I have to say my question, so it's not, is the question whether there's a difference between the two success rates, or whether there's a difference between the success rate that we show and the actual success rate?
Those are both the same question. Those are both the same. Is there what they're saying there is there truly a difference in the population's success rates? What success rates do we see? Can somebody tell me those numbers that we see, are they parameters or statistics? Because they come from a sample. I love it. Right? And what we're always curious about is what the hell is the parameter? Your sample's nice, but I want to know what's true for everybody. So the sample can only point us in a direction, but actually, this is pretty damn good. And later, I'm going to probably come back to this problem if I remember, and we're going to do the math on it once we learn the freaking math. And we're going to get this, close to what number they showed us. So you're doing the math. The samples tell me there's a difference, and then the math tells me there's only a 1 chance in 1,000 that there isn't a difference. So there's more likely that there is a difference. Cool. Now, what the numbers actually are, I have no freaking clue. That's the interesting thing. The best statistics can do for me is verify, yes, it looks like there's a difference. It looks like surgery has a higher success rate than splints. And what's the chances that you're wrong? 1 in 1,000. That's better odds than normal for me. Say again?
Isn't that saying that there's a 1 in 1,000 chance of getting success rates like not lying?
Yeah.
No.
Isn't that chances you're right?
Yeah, exactly. If they are, let me say this again. If in reality the success rates are the same, and I understand this is very strange. You're not used to thinking like this. Statistics is not something inherent. If in reality both populations, surgery and splints, the people that got surgery and the people that got splints, if in reality they both have the same success rates, what's the chances that my samples would show this? 1 in 1,000. So what's more likely? They are different. All right, cool. I like that sound. Oh, I like the look in the face. Oh, I feel better about that now, Jeff. You finally made sense. You wait long enough every now and then. All right, so I think more of us are on the same page. Okay. Should we conclude that surgery is better than splints?
Yes.
In fact, you guys did. Now, if you want to follow that up with, there's a chance we're wrong, that's always true. But what we see definitely leads us to make that conclusion. You with me? Yes?
What is the point of doing a study like this if you're going to put results out that it's only a 1 in 1,000 chance that it's correct?
No, that's a 1 in 1,000 chance that it's wrong.
Well, that you're going to get results like that.
Okay, so there's still that thing. It's kind of backwards. If in reality the populations are the same, there's only a 1 in 1,000 chance that my samples would show those numbers. Since my samples show those numbers, what's most likely? There is a difference. They're not the same. Because there's only a 1 in 1,000 chance that my samples would be like that if they were the same.
If they were both like 80%.
If they were both 80% or something, right? There's only a 1 in 1,000 chance that my two samples would be like this, 92 and 72%, if in reality they were both the same. So what's most likely true? They're both different. You with me? And statistics always has to be like that, because we never know the freaking truth. And that's life. People hate this. People come in here and they're like, I love the fact that the one thing you hate about math is there's black and white, and there's no creativity. And then you come to this guy's like, why isn't it black and white? Why isn't there an answer? Wait, what do you want? So to me, statistics is awesome because it's truthful. And it's helpful. It can never tell us for sure, but it certainly leads us in the right direction more often than not. Right? If anybody plays any cards or anything, if you know pot odds for cards, over the long run, that'll save your ass. Individual games, you might lose a ton of money, but over the long run, you'll be fine. That's what statistics does for us. Okay? All right. So part A, yes, it definitely points us in the direction. The evidence seems to point the direction that surgery is better than splints. If you want to say something about, this is one study, the sample sizes could be bigger, all this kind of stuff, good points. But the 1 in 1,000 chance of that, of us being wrong, I can live with those damn odds. Does the result have statistical significance? In fact, they define statistical significance in this chapter. And 1 in 1,000, that is definitely significant. Right?
So it is statistically significant?
Yes. Cool. So again, just like we saw with Mendel, Those results, those were not statistically significant. Why? They weren't very far apart. This 72, 92, are those far apart? Yes.
Oh, I
And the
see.
1 in 1,000 backs this up. It says, yes, you have statistically significant evidence that these two rates are different.
But that was a different question.
Okay, cool. I like this. This is a very difficult question. That's why I'm going through it with you step by step. I want you to realize that. I'm certainly not saying right now that you should totally understand every little piece of this. But this is going to become very important later in the course. But we're going to work our way there. So it does have statistical significance because of the 1 chance in 1,000. Does it have practical significance?
Yeah.
Yes. Why?
Because you should recommend the surgery unless.
Yeah. There's a definite, there's a huge difference in the success rates. This is my body we're talking about. I want to get something that's going to work most of the time, right? So it definitely has practical significance. I want to be able to get my stuff healed so I can do things like take notes. Should surgery be the recommended treatment for carpal tunnel syndrome? Now, this is an interesting question. What do you think it is that, which is a valid argument, in which I saw a movie recently called 1 Week, where this dude was diagnosed with cancer and he goes to Canada and I don't know if you guys have ever seen the movie. You never seen that movie? You should watch it, it's pretty good. But they say that the statistics are interesting, but I'm working with
The facts.
and a person, right? So what if you personally don't want to do surgery, or if you have something that you can't have anesthesia, local or general, that something might happen bad to you, your heart's really weak or something, right? You with me? So Part D seems to be, Part A says surgery is better than splints in general. Well, Part D is where we go, you got to take it individual case by case. If there's certain things that would make splints better for a person, even though it's got a lower success rate, you don't want to kill them with something else with the surgery. You with me? So that's what Part D is saying. Okay, cool. Yep.
For Part B, you said that it was statistically significant because there was a 1 in 1,000 chance of
Yes.
getting success rates like that. But wouldn't it? I thought it would be statistically significant because there's a 20% difference between the two.
No, it's not good enough. Not good enough. And here's a good example. If I go out and I take a sample of gas stations. So let's say, what do you think the average gas price is right now?
$4.
For like a basic.
$4.
So I go out and take a sample of gas stations, and in my sample I get an average price of $6. And I go, you're insane. What would you ask me? What should you ask me? What have I not told you?
How big was
Anything?
your sample size?
How big was it? 2. Up in Rancho Bernardo, Carmel Valley. They always have. You ever notice they have like $5 and something when everybody else is $4? It's crazy. So I don't want to go up there. Go to my Arco down the street. Yeah. You with me? So, yeah.
So then, why was it statistically significant for Mendell's sample?
It wasn't.
It wasn't. Yeah, they weren't far enough apart.
So if the yellow was say like 40%,
Then it would be kind of obvious that it is. Yeah. So, and in this case, it's kind of obvious it is too. They made it a little bit too obvious here, but they gave us the 1 chance in 1,000. They gave us the number so I can come back and do it again, so I can show you the math later when we learn it. And the 20% in this case is kind of obvious, but in general, I can't say. Like I was saying up here, what number would be far enough? We don't know. We have to get the math, and we have to figure out how to assign that subjective number, that benchmark. We don't know that yet. So you almost can't say anything until you do the math. You can't just say, well, yeah, that seems like a lot. It depends on the sample size. It depends on a few different things. All that show up in the formula. Okay. Yep.
So the B again is the part that's statistically significant is the fact that it's 20% difference. But the reason, no, wait, okay, I don't understand it all then.
Oh, shoot. All right. Let's see. Look here.
I think you.
Where do they first mention it? There we go. Oh, I can't remember where they first mentioned statistical significance.
I think that's it.
Yeah. So here's an example. They like that 1 in 1,000 chance, and you'll see why later. It's kind of a standard benchmark, but it doesn't have to be that. But it's one that's used a lot for showing statistically significant evidence for something. Your question really is, again, when I found the $6 gas, and I think everybody was cool with that example, that I was full of shit there, right? Why was I full of shit? You're like, it's 412, and I go, my sample said it's $6. Why am I full of shit? I went to 2 gas stations, but it's almost a $2 difference. That's huge. We're only at 4 and 6. $2 is relatively big, but still, I have to know my sample size. I have to know my benchmark. I have to know all these other things to kind of really tell, is it far enough away? So the idea of what's far enough away is going to become very important. So as we go through the class, we're going to first have to learn in statistics, how do you measure distance? And then we can start talking about how do you show how far apart two things are, and then we can say, well, what's far enough away, and then try to show that it is far enough away.
Well, what the question asks, is the result, so is it asking about the 2 percentage numbers, or is it asking about the 1 in 1,000?
Those are, you just said the same thing twice, because the 1 in 1,000, shoot, I changed the page. The 1 in 1,000 is referring to the 72 and 92, and yeah, exactly. So if, shoot, what'd you for?
So there's a chance that those are correct, and then there's the chance that you'll have a good.
So let's say instead this was 82%.
Yeah.
Then this would not have been 1 in 1,000. It would have been maybe 1 in 200 or something.
Okay.
Because they're a lot closer together now, so there's more chance that it is the same. You with me?
Yeah.
So when you say is it one or the other, I can't. It's both. At the same, it's one thing. Those 72 and 92 and those sample sizes led me to this number. Yeah. Doing the math. So you can't say it's one or the other. Those led me to this. Yeah. But what can I get that directly from? This. I can't get it directly from the numbers themselves because I don't know till I do the math.
And so when you say it does have statistics?
It does have statistical significance. I know. Statistic. I know.
And that's because it's
a little closer to reality, right? Statistics. I'm taking
and that's because it's not small enough to not matter. Is that right?
It's small. All right. I know what you're saying. It's small enough to matter. It's actually the way it is. It is definitely small enough. If it was less of a chance, it'd even be more likely that they're different, right? So the smaller that probability is, the more significant it is.
So it is significant.
Oh yeah. And that's the weird thing. That's the weird. You were used to being like the higher the better, but this is like playing golf. The lower the better. The smaller that number is, the less chance there is that they're the same in this case. So it's statistically significant evidence that they are different. You with me? Cool. Yeah.
So, for instance, like the $6 one, would that be because the sample size is so small that
Yes.
it would be
If
much
I did the
easier
math,
to get it?
The sample size is in the equation. That's the cool thing. And we all know coming in. You knew before day one that the bigger the sample, the better. So it's really cool to see the sample size in the equations. The equations say, shit, if that gets bigger, the whole thing gets smaller, it's more, that kind of thing.
So the idea of getting $6 would be really easy if you're only doing 2 random
Exactly.
ones. So then you would be like a chance of 1 in whatever, like 5 or something. Not
Oh yeah, it'd be much better chance that they're
Yeah.
actually the same price and not different.
Right.
Yes.
What wouldn't have statistical significance?
Is slightly subjective. So right now, the best we can do is say if it's really small, 1 chance in 1,000 is pretty good. Where we just aren't at the place in the math yet. And I understand this. We're not in the place in the math yet to know how to calculate, and we haven't got to the concepts yet to know how to set the benchmarks. So in chapter 3, we're going to learn a few things that get us closer to that, and then we're going to learn the math, and then we're going to put the two together. All right, so just got to hold on. Yes, sir.
But the problem said like 1 in 4 chance of them being the same.
Yeah, so right now they have to make it really obvious. Because we don't know yet the concepts enough to really set those. So they gotta make it really, so 1 in 4 chance, well shit, I'll play that game. Right? 1 in 1,000 chance, well, maybe I'll play as long as it's not that expensive, but I mean that's getting really difficult to win then, right? Alright. How we doing so far? Okay, some of you guys are sleeping your eyes open. It's a skill I never mastered. Okay. One thing I want to have time today is I want to do some stuff with the calculator. And I brought some extras here. But are there any other questions from chapter 1? Okay, all right. So I want to get to chapter 2 a bit, and then we're going to talk about the calculator. Oh, cool. Actually, I'll tell you what, let's do this. I kind of do this normally anyway. Let me tell you this right now. This is a good note to take. Section 2.2 and 2.3, do those together. Don't turn in section 2.2 and then try to do 2.3 because 2.3 refers back to the work you did in 2.2. With me? So in 2.2 you're going to analyze data, and 2.3 you're going to make a picture using what you did. So it really sucks when somebody turns in 2.2 and like, I can't do my 2.3 homework. So do those together. Okay, cool. What I've done here, 32 people so far have answered the survey. So these are the ages of those 32 people. Okay, so we're going to analyze those ages. Sounds exciting, I know, but. So who needs to borrow a calculator first? Let's do that. Holy shit. Alright, I don't know if I want to make this a mad dash. I'm gonna get it. Alright, let's see if I can do this. Those of you sitting near each other can share. You guys can share. You're special, you get one. You two here can share, right? Here, do you have one? Oh yeah, okay. Me too. Okay, cool. Alright, there. You guys okay? Do you have one? Or you guys both need it? Oh, okay. Maybe. Let's see. You guys here share. Yeah, what do you guys share? Who else we got? Can you guys share? Cool. Oh, sure. Who else is it? Right. Alright, I got one left.
Is this more? Keep it.
No.
No. I need one.
Alright, somebody near you with one. Can you guys share there? You guys, or you, okay. So, I have this cool little emulator program. Whenever this loads up. So the first thing, if you've never used this, and how many of you guys have actually never ever used the TI before, ever? Okay. Didn't mean to point you guys out. If you've used a scientific calculator before, then it's just like that, but you can see the whole problem on there at once. You know, the little basic ones when you hit 7 times 6 and the 7 disappears. And it really sucks when you want to put a long list of something and you're like, what did I put in so far? So I'll show you a couple basic things, and then we're going to jump into the stats stuff. Let's see. Crank this over. My color scheme. Okay. All right. So, for example, real quick, 7 minus 6. So I'll make sure a calculator is working correctly. There's a minus button and there's a negative button. So if you do 7, negative 6, anybody have an idea what it might do? In this case, it actually has a syntax error, right? Because there's no operation between those. That's a 7 and a negative 6. The nice thing is, notice this happens very often. You do something, it has a syntax error, but then it has a go-to option. And look what it puts the cursor on when you say go-to. It puts the cursor right on top of the problem. So you go, oh, I put the wrong minus sign in there. I'm good now. Okay. Very, very basics. Here's a really important, if you accidentally hit something, you're like, where the hell am I? Second mode, second quit will always get you back to the home screen. You with me? So it's very easy to hit some button accidentally, like, what the hell is this shit? Second quit gets you back. Let me see. Anything else I want to tell you guys? It knows order operations, so if you do this, what should the answer be?
3 or negative 3.
All right, it's better. Negative 3. Because it'll do the multiplication first before it knows order operations. So you got to be careful. Sometimes it's bad. Right? You got to be garbage in, garbage out. So we have to be careful how we put things in. Let me think. Anything else I can think of that you guys need right now? Here's the clear. If you got too much stuff on your screen, hit clear. Then I say, let me show you something really quick. So let's see right here. I do 8 times 9 minus 6. And and then if I hit times again, it's just going to pick up. See how it says ANS? That's the answer button. You actually have it right there. That's temporary memory. It's got the last number that showed up on the screen, and trust me, it's going to be very useful in this class. We have this huge calculation, then we have to do more with the number, and you don't want to put 4.87653. So if I want to multiply it by 2, there you go. If I want to subtract 7, there you go. What if I want to take the square root of that, though? First off, where's the square root button? Good. So second, that's like my shift key, and it's over the x squared. There it is, the square root. Square root of that, it's just 125, but work with me. I can hit second negative sign. You get ANS, and that's the last number that was on the screen. Square root of the last number on the screen, there you go. So that's the square root of 125. Makes sense, because 11 squared is 121. That sounds about right. Cool. How are we doing so far? So hopefully for most of you guys, this should be old news. All right, that's enough of that. What's the most important button on this probably for us? Yeah, the one that says stat. That's a good. So hit stat. And what it comes up with, this is going to be a series of lists that we can put data in. We can calculate stuff based on those. We can do certain tests to test if there's statistically significant difference or not. You with me? We're not quite there yet, but if I hit the edit button right now, it should open up several lists. Now, if you're borrowing a calculator from me, or you're borrowing a calculator from somebody else, you might have stuff in there. You with me? Are we all on the same screen? So go to stat, bless you. Stat, edit. So we're all there. Somebody have stuff in there? Some of you guys should. Definitely some of you guys with my calculators. So one way to do it is you go up to the list, you hit the up arrow, and then you hit clear, enter, and that'll clear it out. So if you got stuff, 5, 3, 2, 1, earth, field, no. You can go up to the L1, hit clear, enter. Now if you go up there and you hit delete, that'll suck. Because now I've deleted my, and then you panic and you hit, no, what's going on? So if you do that, or if you borrow a calculator and all the lists are funky, they're renamed, weird shit and all this kind of stuff, just go to Stat, Setup Editor, number 5. And then when you go back in, it's back to normal. Let me do what I forgot to do before you guys all freak out and everybody's taking notes. Here's that calculator Bible. Did anybody print this thing out from the website, calculator Bible? A few people are, because I didn't bring enough copies for everybody. Anybody in this room have it already? You do? Any of you guys in the back have it already? You already have it printed out? You have it already? Okay. Anybody here? You have it already? You got it? Oh, Anybody here have it already? Make sure you have a front and the back, by the way. My printer likes to mess with me. Anybody here have it? Anybody here have it already? No? Anybody here have it already? No? Shit. I think you two rows are going to be sharing here in a minute. So 8. Okay. Anybody here already have it? No? 2, 3, 4. Okay. Just to remind you, for those of you who were not lucky enough to get it today, just go to Jeff Waller, go down, there it is, Calculator Bible, print that bad boy out. Cool. So real quick, part A is going to be what we're going to do part of today. And it's going to be important for chapter 2 and chapter 3. And then part B is going to be important for the last part of chapter 3. And on the back, there's some more advanced stuff, chapter 6, 7. Okay. All right, so the first thing I want to do, is everybody to the point where they have the screen like this now? Nice blank, L1, L2, L3. If you hit an error or something while we're doing this, just immediately let me know. I don't want to leave you behind somewhere. So what we're going to do is something really exciting that happens in statistics. We have a lot of data analyzed in this class, and sometimes you just got to sit down and input the damn data, right? This is those beautiful summer jobs, work from home. I would never do this because you're just inputting freaking data or whatever. Screw it. But that's the bane of the statistician. We have to do this. So let me put this data back up here, and I want you to put all the ages into list 1.